Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing bedtime astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Astronomy's role in the birth of calendars. Imagine a world without calendars. How would we track the changing seasons, predict floods and harvests, or mark the passage of years? The answer lies in the vastness of the night sky. Our ancestors, far removed from the convenience of digital clocks, were the first astronomers. They looked up, not just in awe, but in a desperate need to understand and navigate the flow of time. The earliest timekeeping methods were deeply intertwined with celestial observations. These weren't mere stargazers. They were meticulous record keepers, meticulously noting the positions of the sun, moon, and stars throughout the year. This wasn't just idle curiosity. It was a matter of survival. Predicting the return of floods, the arrival of hunting seasons, and the precise timing of agricultural activities all hinged on understanding the rhythmic movements of celestial bodies. These early observations laid the groundwork for the very first calendars. They were simple systems, often based on readily observable phenomena. But within this simplicity lay the seeds of a profound connection between astronomy and our concept of time. The night sky became a giant clock, its celestial bodies the hands marking the passage of days, months, and eventually, years. The daily rhythm, Earth's rotation, and the birth of the day. The most fundamental unit of timekeeping, the day, is a gift from our own planet. Imagine standing on a spinning merry-go-round. As the platform rotates, the scenery around you seems to move. This is analogous to Earth's rotation on its axis. Every 24 hours, the Earth completes one full rotation, causing the sun to appear to rise in the east, trace an arc across the sky, and then set in the west. This daily celestial dance provided the most basic unit for our calendars, the day. Early humans, lacking sophisticated instruments, likely relied on the changing position of the sun to gauge the passage of time. As the sun climbed higher in the sky, it signaled the approach of midday. Its descent towards the horizon marked the beginning of evening. The complete disappearance of the sun signified the arrival of night. This simple observation, the sun's daily journey across the sky, became the cornerstone of the day, the fundamental building block for all calendars that would follow. The moon's phases, a celestial timekeeper unveiled. Beyond the ever-present sun, another celestial body played a crucial role in shaping our concept of time, the moon. As Earth's natural satellite, the moon orbits our planet, constantly changing its appearance. This cycle, taking roughly 29.5 days, showcases the moon in a variety of phases. A thin crescent, a full, luminous orb, and everything in between. These phases were readily observable, even to the naked eye. Early civilizations recognized the moon's potential as a timekeeping tool. Cultures around the world, from the Babylonians to the Chinese, developed lunar calendars based on the moon's cycle. A new month often began with the appearance of a new crescent moon. Full moons became significant markers within the month, used for religious ceremonies or social gatherings. The lunar cycle, with its predictable rhythm, offered a reliable way to measure the passage of time, particularly for shorter durations like months. Chasing the sun. The quest for the perfect year. While the day and month were established through everyday observations, tracking the year presented a greater challenge. The key once again lay in the heavens, but this time, the focus shifted from the daily dance of the sun and moon to the sun's annual journey across the sky. Imagine standing on Earth and looking out at the distant stars. Throughout the year, the constellations appear to shift in their positions. This is because Earth isn't simply spinning on its axis. It's also revolving around the sun in a nearly circular path. As Earth travels in its orbit, the backdrop of stars against which the sun appears to move slowly changes. This annual trek of the sun against the constellations is known as the ecliptic. By meticulously observing the sun's position relative to specific constellations throughout the year, early astronomers began to grasp the concept of a solar year, the time it takes for Earth to complete one full revolution around the sun. This period, roughly 365.25 days, became the cornerstone for solar calendars. Calendars based on the solar year were crucial for agricultural societies. By understanding the sun's annual cycle, farmers could predict the arrival of seasons, plan planting and harvesting times, and ensure a successful yield. The relentless pursuit of accuracy. Bridging the gap. The early solar calendars weren't perfect. The Earth's revolution around the sun takes slightly longer than 365 days, approximately 365.2422 days. This seemingly small difference accumulates over time, causing the calendar to drift out of sync with the seasons. For instance, a calendar based on exactly 365 days would be off by about 6 hours every year. Over several years, this discrepancy would lead to significant problems, with planting seasons falling outside the optimal time frame. Astronomers throughout history have grappled with this challenge, seeking to create calendars that accurately reflect the Earth's revolution. The Egyptians, for example, developed a calendar based on the annual flooding of the Nile River, which coincided with the heliacal rising of Sirius, the brightest star in the night sky. This approach provided a relatively accurate solar calendar, but it wasn't universally applicable. The quest for a truly accurate solar calendar continued for centuries. The Romans, under Julius Caesar, implemented the Julian calendar in 45 BC. This calendar introduced the concept of a leap year, adding an extra day every 4 years to account for the leftover fraction of a day in the Earth's revolution. While the Julian calendar was a significant improvement, it still had minor inaccuracies. Refinement and reform. The ongoing legacy of astronomy. The story of astronomy's influence on calendars doesn't end with the Julian calendar. Even with the leap year system, The calendar drifted out of sync with the seasons by about 11 minutes every year. This discrepancy prompted the development of the Gregorian calendar in 1582, which is the calendar we use today. The Gregorian calendar refined a leap year system, introducing additional rules to ensure long-term accuracy. The influence of astronomy on calendars extends far beyond the basic units of time. Even today, astronomers continue to track the Earth's rotation and revolution with incredible precision, using atomic clocks and celestial observations. This ongoing pursuit of accuracy ensures that our calendars remain aligned with the celestial cycles that govern our planet. Civilization calendars. A global legacy. Astronomy's influence on calendars wasn't limited to a single region or culture. Across the globe, civilizations independently observed the heavens and developed their own timekeeping systems. The Maya calendar, for example, was a complex system based on a combination of solar and lunar cycles. They tracked a 365-day solar year alongside a 260-day ritual calendar, creating a sophisticated system for agricultural planning and religious ceremonies. The Chinese calendar, another fascinating example, is a lunisolar calendar, a hybrid that incorporates elements of both solar and lunar cycles. Each year in the Chinese calendar is named after an animal, creating a 12-year cycle that repeats. This calendar system has been used for millennia, not just for tracking time, but also for astrological predictions and cultural celebrations. These diverse calendars, each reflecting the unique astronomical observations of their creators, stand as testaments to the universality of humanity's desire to understand and measure time. By studying these calendars, we gain insights into the scientific understanding and cultural values of past civilizations. From sun and moon to beyond, the expanding role of astronomy. Beyond the basic units of time, astronomy has played a role in shaping our understanding of longer time frames. By studying the motions of celestial bodies like stars and nebulae, astronomers can estimate their ages and the age of the universe itself. Radioactive dating techniques, based on the decay of elements within meteorites and rocks, have provided further insights into the timeline of our solar system and Earth. The vastness of astronomical timescales dwarfs human history. Understanding these timescales allows us to place ourselves within a grander cosmic narrative, appreciating the immense age and ongoing evolution of the universe we inhabit. The future of timekeeping. A continuing dialogue. The story of astronomy and calendars is far from over. As our technology advances, so too does our ability to observe and measure time with incredible precision. Atomic clocks, based on the natural vibrations of atoms, can keep time with an accuracy of 1 second in billions of years. These clocks are becoming increasingly crucial for scientific research and global communication. Astronomers continue to refine their understanding of celestial mechanics, leading to even more accurate models of Earth's rotation and revolution. This ongoing pursuit of precision ensures that our calendars remain aligned with the celestial rhythms that govern our planet. By looking up at the night sky, Our ancestors not only found wonder and inspiration, but also the tools to measure, understand, and navigate the flow of time. Calendars, born from celestial observations, have shaped our societies, governed our agricultural practices, and influenced our cultural traditions. They serve as a constant reminder of the profound connection between humanity and the universe, a connection forged in the fires of our celestial curiosity.